this video, I'm going to introduce corrplot, an R package that is used for exploratory data analysis, particularly to examine patterns of correlations of a number of variables. So we're going to use one of the built-in data frames in R, the mtcars data frame. And if we take a look at the structure of the data frame, we'll see that it has 11 different variables. All of them are numeric. If we wanted to calculate the correlation between two variables, we can do it fairly simply with the cor command. So here's an example. I've given displacement as one of my two variables and horsepower as the second. So I stipulated both by denoting that they're both in the mtcars data frame. And I run that line and I find that the correlation coefficient is 0.7909486, as you can see down in the console. To get a table of all pairwise combinations of variables, I can simply use cor with the name of the data frame. So I simply run this line of code, and you can see that I have this table which gives all the possible combinations of two variables, and for each pair of variables it gives the correlation coefficient. I'm going to save this table as an R object. I'm going to call it MAT for matrix. So we'll save that, and you can see that my MAT object now appears up here in the global environment. What we will do now is to turn to corrplot, a graphical analysis package to look at correlation coefficients of a number of variables at once. So if you haven't installed corrplot, then you should do so with this install packages command. And I've already installed it, so I'm just going to require it. And now to use corrplot, all we have to do is to feed corrplot the matrix of our correlation coefficients. So, and I created that earlier, so I just go corrplot and then MAT, and I get this very nice figure here. I'm going to zoom in on it so we can see a little better. But what you can see is that I have all of the 11 variables on both the horizontal and the vertical axis, and I also have a spectrum over here. So dark red would indicate a very strong negative correlation, dark blue would indicate a very strong positive correlation. Along the diagonal, we see the autocorrelation of the variable. So the variable correlated with itself, and of course that value is always going to be 1. But we also see that the other correlations are shown in two ways. One is that if they are red, that indicates a negative correlation, and if they're blue, that would be a positive correlation. But the intensity of the blue and the size of the blue is going to be indicative of the strength of the correlation. So this relatively light blue and small circle would indicate a relatively weak positive correlation. This light-colored orange circle would indicate a very weak negative relationship, and a value like this blue circle here is nearly as large as the perfect correlation, and that would indicate a very strong positive correlation. There are tweaks that we can do to these corrplots, and what I'm going to do now is to specify the method. And you note that method has 7 possibilities. I can use circle, which is the default, or I could indicate these individual correlations with squares, ellipses, actual number, shade, a color, or a pie. And I'm going to use ellipse for now. Put that in double quotes. So we'll zoom in on this figure as well. So the ellipse shows lots of information as well. The ellipse essentially is showing a plot of the two variables. So if the tendency is for the ellipse to be oriented from lower left to upper right, that would be indicative of a positive correlation. And any ellipse that's going from the bottom right to the top left would be indicative of a negative correlation. And that, of course, could be confirmed by looking at this spectrum that you could see here. The width of the ellipse is going to indicate the strength of the correlation as well. So here along the major diagonal, we have perfect correlations, and the ellipse is very flat. Essentially, it's linear. These bloated ellipses here would indicate very weak correlations. And again, we're using color to represent negative with the orange or positive with the blue figures. I'm going to do another couple of tweaks to our figure here. What I'm going to do is to order the variables so that I can more easily detect patterns of high correlation and low correlation among the many variables that I have. I'm going to use the AOE method to order. AOE stands for the angular order of the eigenvectors. I've also changed the method that I'm going to be using this time. I'm going to use color. And I'm also going to add the correlation coefficients. I'm going to add them in a gray color. You could put any color you want here. Gray seems to be a pretty good color to see against both the blue and the orange backgrounds. So we'll run this line and we'll zoom in. So you can see that the entire block is filled in. I don't have a geometric figure, a circle or a square, but the intensity of the color is going to be queued to the strength of the correlation coefficient. But by ordering it, what you can see is that I have all of the variables that are highly positively correlated are located here on the upper right, or also lower left, since this is a symmetrical representation. And variables that are negatively correlated are going to be concentrated down here, the lower left or upper right portion of the screen. So it makes it a little bit easier to easily see which variables are negatively and positively correlated with each other. I can also plot different types of information on the lower left and upper right of the figure. And I do that by using the corrplot.mixed function. So I will run this command, and again I'm going to order based on AOE. So here I have the correlation coefficients down in the lower left, and I have the same information shown in the upper right, but using the color and size of the circles to represent that same information. Corrplot has lots of other possible features that you can use, and I would encourage you to go to this excellent vignette. And here's the website for that. I broke the website into 2 lines to make it appear completely, but you can copy this information here, put it in a browser, and you will find lots of good information on other features of corrplot, a very powerful tool for exploratory data analysis.